Okay, we are going through our last section in Unit 3, double angle identities. And these are special cases of the sum or addition identities that occur when two angles have the same measure. Okay, and these cases are called double angle identities. So what's going to happen here is I'm going to give you all of the identities, and then I'll go through and take care of the proofs. So first of all, our double angle for sine is 2 sine theta cosine theta. And this comes up a lot, especially when you get to calculus. The tangent, the double angle for tangent is 2 tangent theta over 1 minus the tangent squared. Okay, and then cosine is special, based on the original, which is cosine squared theta minus sine squared theta. If we make substitutions using the Pythagorean identity, one variation is 2 cosine squared theta minus 1, and then the other would be 1 minus 2 sine squared theta. Okay, so let's start with the proof for the double angle for sine. So sine double angle. And as stated before in the very beginning, you start off with the sum identity or the addition identity. So in step number 1, we have the sine of alpha plus beta, which is equal to sine alpha cosine beta plus cosine alpha sine beta. Okay, and this is the sum sine ID or sine sum ID. It doesn't matter. Okay, so in step number 2, we are going to write what's called a let statement. So we're going to let alpha be equal to theta and beta be equal to theta. Okay, so this is what's known as a let statement. Okay, in step number 3, we're going to make that substitution. So this is the sine of theta plus theta. Okay, so what I need to do is wherever I see an alpha and a beta, I'm going to put in a theta. Did not mean to rhyme that. Sine theta, cosine theta, plus cosine theta, sine theta. Okay, and this was a substitution of step number 2, okay, into number 1. Okay? Alright, so when you add theta plus theta in step number 4, you get sine 2 theta, okay, which is up here. Alright, and then you're going to simplify. You've got sine cosine and essentially sine cosine, and when you have 2 of them, this is 2 sine theta cosine theta. That's your proof. Okay, that's the double angle for sine. Okay, the double angle for cosine. So we're going to do the same thing. We'll start with the sum for cosine. So cosine of alpha plus beta, remember this one's a little bit different, is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay, and this is cosine sum ID. Okay. Then we'll do again a let statement. Okay, and this is just a let statement. And again, this is a proof as to how we get an identity. So it's not the verification, it is a true proof. So now we'll make our substitution in step number 3. And you're going to see repeats of some of these steps multiple times. Actually, I forgot to put here simplify. Okay, so cosine of theta plus theta is equal to cosine theta cosine theta minus sine theta sine theta, and now we're going to simplify. So this is substitution number 2 into number 1. So this is the double angle cosine 2 theta is equal to cosine squared theta minus sine squared theta. And this is just simplify. Okay, so this is my double angle for cosine. This is my double angle for sine. Okay, so one of the other variations here, and I already told you this, is if I took this step and said cosine 2 theta, if I make a Pythagorean substitution, meaning 1 minus sine squared theta minus sine squared theta for the pith ID right here, I'm just going to put it right here, I would end up with cosine 2 theta is equal to 1 minus 2 sine squared theta, which is the very bottom. So this is another variation if I simplify. Okay, and then another one where if I were to pick off at step 5, pick up, this is cosine 2 theta, okay, is equal to cosine squared theta minus 1 minus cosine squared. And you guys actually saw that in that problem number 10 from your homework. So then cosine 2 theta, here this would be pith ID. It's the same right here. Is equal to, so when I distribute, this becomes -1 and positive, so this is 2 cosine squared theta minus 1. So these coincide. So this is all 3 cosine. Okay, the last one is our tangent. So tangent, double angle. Okay, so again we're going to start with the sum for tangent. Tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent beta. Okay, this is tangent sum ID. So then in step number 2, we're going to do our let statement. So we're going to let alpha be theta and beta be theta. So this is our let statement. Then we'll make our substitution. So we have the tangent of theta plus theta is equal to tangent theta plus tangent theta over 1 minus tangent theta tangent theta. And this is substitution. Substitution. I'm writing too fast. Substitution of number 2 into number 1. Okay, let's simplify. Tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. And I think I'm done. There you go.